Introducing two trigonometric identities. In Core 2 we're going to use two trigonometric identities which you will not have used before in Core 1. Now you must learn these two trigonometric identities because you are likely to use them if you're asked to prove two things are equal to each other. So the first trigonometric identity is sine squared theta plus cos squared theta is always equal to 1. You can test this on a calculator if you want to. So sine squared theta plus cos squared theta is equal to 1. Of course, we could rearrange this to make sine squared theta equal to 1 minus cos squared theta, or vice versa. And the other trig identity is that tan theta is always equal to sine theta divided by cos theta. So tan theta is equal to sine theta divided by cos theta. Now we're going to use these two identities to simplify the following. So 5 minus 5 sine squared theta. Now the big hint here is because we've got sine squared theta, we must be using this top identity when simplifying. Now we've got sine squared theta, so we're probably going to have to rearrange sine squared theta plus cos squared theta equals to 1 to 1 minus cos squared theta is equal to sine squared theta. So let's substitute that into our expression. So 5 minus 5, 1 minus cos squared theta. So if we expand the bracket, we get 5 minus 5. Minus minus becomes a plus 5 cos squared theta. Well, 5 minus 5 becomes 0, so you're just left with 5 cos squared theta. For question number 2, sine 2 theta divided by the square root of 1 minus sine squared 2 theta. Well, at the moment we can't do anything to the bottom of the fraction here. We can't square root it because it won't be as simple as just putting 1 minus sine 2 theta. But we can, however, change this bottom. Instead of having sine squared theta, let's try using our fact we just wrote down here and using it with 1 minus cos squared 2 theta. So let's try and change in this bottom here to use cos squared 2 theta. So sine 2 theta divided by square root of 1 minus cos squared 2 theta. So if we just sort out the bottom of this fraction now, we're going to have 1 minus 1 which becomes, which cancels each other out, and we've got minus times a minus which becomes a plus, we've got cos squared 2 theta. Now we can change this bottom to just cos 2 theta because we can just square root. So we've got sine 2 theta divided by cos 2 theta. And using our second trig identity, we know that tan theta is always equal to sine theta divided by cos theta. So this is equal to tan of 2 theta. Right, this is a more typical exam style question where we've got show that cos to the power of 4 theta minus sine to the power of 4 theta all divided by cos squared theta is always identical to 1 minus tan squared theta. Now, the step here that you need to be able to identify is that this cos to the power of 4 theta minus sine to the power of 4 theta is actually the difference of two squares. Because hopefully you might be able to spot at the top is the same as cos squared theta plus sine squared theta, and the second bracket is cos squared theta minus sine squared theta. all divided by cos of 2 theta. Now it's really important when you're solving trig identities or showing that two things are equal, like in this case, you only work on one side of the identity sign. So we're looking at the left hand side only, we don't want to be looking at the right hand side. Now, because we're using this tan squared theta we're trying to show, we must assume at some stage during this that we're going to have sine squared theta divided by cos squared theta, which would give us tan squared theta. Now, what we've just done by doing the difference of two squares is we've found that this bit here would be equal to the value of 1, because we know that cos squared theta plus sine squared theta is equal to 1. So we've got 1, and all we're left with now on the top is cos squared theta minus sine squared theta, that's all divided by cos squared theta. Now, what we can do at this stage is we don't have to leave this as one fraction. We can split it into two fractions. So we can split it into cos squared theta over cos squared theta, and we can split it into minus sine squared theta over cos squared theta. Now we're very close to what we want now, because we know that cos squared theta divided by cos squared theta must be equal to 1. And we know that sine squared theta divided by cos squared theta must be equal to tan squared theta, from tan theta equals sine theta divided by cos theta. And we've actually shown now that the left hand side is equal to the right hand side of the identity that was given to us. So remember, you must learn those two trig identities, that sine squared theta plus cos squared theta equal to 1, and that tan theta is equal to sine theta divided by cosine theta.